Record.
Hello, I am Sohail Ahmad, Assistant Professor, Department of Mechanical Engineering, Government Engineering, Ramnagar. I welcome you to this session 1 of Fluid Power Engineering for 5th semester. Subject code is 18ME55. This module consists of components and hydraulic circuit design control components and hydraulic circuit design components. So before I go to this module, I'll give a brief introduction about fluid power engineering. This fluid power engineering refers to the branch of engineering that deals with the high use of high pressure fluids, both liquids and gases. So that these high pressure fluids can be used to generate, transmit, and control power. So any industry, if we take, the basic source of power comes from three sources. That is, it is also called as prime movers, source of energy, electrical, mechanical, and fluid power. So these, the use of electrical prime movers such as electric motors and mechanical prime movers such as internal combustion engines is very common. So electrical power is transmitted through suitable power cables, while mechanical power is transmitted through gears, shafts, belts, pulleys, etc. So the third and the most common type of power source is the latest hydraulic energy or hydraulic power. So this hydraulic power uses high pressure fluids, so both liquids and gases, for the generation, transmission, and control of power. So the fluid power engineering is divided into two branches: hydraulics and pneumatics. So this hydraulics, it is derived from a Greek word hydra, meaning fluid or liquid. So the pneumatics, it is also derived from the Greek word pneuma, meaning air. Generally, air or nitrogen is commonly used. So with this, then we have the advantages of these fluid power systems. List a few advantages of fluid power systems. So power multiplication. The first advantage of this fluid power system is power multiplication. Then we have power transmission, easy to transmit power. Then there are no moving parts, constant force and torque, then ease of control, and lastly, it is safety and economical. These are some of the advantages of fluid power systems. And coming to the applications, these fluid power systems has wide range of applications used in industries nowadays. So the hydraulic jack used for lifting the loads, hydraulic power steering mechanism used in automobiles, hydraulic lifts trucks in aircrafts, robots, in earth moving equipments, in power process for sheet metal and forging operation. So these are some of the important applications of fluid power systems. So this brief introduction, I'll move on to the uh, module 3, that is control components and hydraulic circuit design. So before that, let us see what are the course objectives of this subject. So it provides to provide an insight into the capabilities of hydraulic and pneumatic cylinders, to examine concepts centering on sources of pneumatic power, rotary and linear actuators and distribution systems, exposure to build the pneumatic circuits related to industrial applications, and lastly, to familiarize with logic controls and troubleshooting. These are the course objectives. Next, what are the course outcomes? So with this, the course outcomes, there are 4 course outcomes. Visualize how a hydraulic or pneumatic circuit will work to accomplish the function. Then we have design an appropriate hydraulic or pneumatic circuit or combination circuit like electrohydraulics, electropneumatics for a given application. Then select and size the different components of the circuit. And lastly, develop a comprehensive circuit diagram by integrating the components selected for the given applications. These are some of the course outcomes of this subject. Then the control components. This is the third module in part A. So these are the contents, components, directional control valve, and types of valves. So before this, I'll give a brief introduction about what are the control components. So the three major segments of a hydraulic system are the power supply, the control unit, and the output. The first two modules deals with the power supply and the output. The output devices such as power supply systems such as hydraulic pumps and motors. Then the output devices are actuators such as cylinders and motors. The major segment is the control system that assists in between the source and the output segments. So the control system is the most important element in a hydraulic system. Control of fluid power is achieved through devices called valves. So these valves, hydraulic valves, are basically mechanical units which may hydraulic mechanical units. They can be either electrical or optical units also. Valves control the flow by means of movable elements that open and close, partially blocking the openings in a passageway. So, coming to the classification of these hydraulic valves, so the first classification is the directional control valves. So this is a valve, it is abbreviated as DCV, directional control valves. So these directional control valves, they control the direction of flow of a fluid in a hydraulic system. The second classification, the basis is pressure. So it is called as pressure control valves. So abbreviated as PCV. So these pressure control valves, they control the pressure of a hydraulic fluid inside a hydraulic system. Then either they increase the pressure or decrease the pressure, or they can maintain a constant pressure in a system. So in this way, this pressure control valves, they protect the system. Whenever the system pressure increases beyond a certain limit, they lower the pressure and they protect the system from any damage. Then the third classification is flow control valves, abbreviated as FCV. That is, they control these types of valves. They control the flow or the discharge of a fluid in a hydraulic system. So again, these directional control valves, they are again classified are subdivided into check valve. So the first is called check valve, or it is also called one check. It allows the fluid to flow in only one direction. That is, it does not allow the fluid to flow in the opposite direction. Flow occurs only in one direction. That is called as check valve. Then we have sliding spool valve. The third one, solenoid control valve. Then we have poppet valve. So in poppet valve, there will be a movable poppet which comes and sits in between the flow, blocking the flow and allowing the flow in one direction. So then we have rotary valve, and lastly we have pilot operated valve. So in directional control valves, the directional control valves control the direction of flow of a fluid inside a hydraulic system. These directional control valves, again, they are classified into 6 types: check valve, sliding spool valve, solenoid control valve, poppet valve, rotary valve, and lastly we have pilot operated valve. Then the second one is called as pressure control valves. So as the name itself indicates, it controls the pressure of a hydraulic fluid inside a hydraulic system. So these pressure control valves, they are classified into 4 types: pressure relief valve, pressure reducing valve, pressure sequence valve, and counterbalance valve. And among these, the pressure relief valve is the most widely used valve, uh, and the pressure reducing valve is also used, which reduces the pressure if the pressure system pressure increases beyond a certain limit. So this is about pressure control valves which control the pressure. Then the last classification is flow control valves, which is abbreviated FCV. These flow control valves, they control the flow of fluid in a hydraulic system. So again, these flow control valves, we have three types: needle flow control valve, non-pressure compensated flow control valve, pressure compensated flow control valve. So this is a brief introduction to the control components, the third, which is the third major segment in a hydraulic system. The main function of these control components is it does three functions: control the direction of flow of a fluid, it controls the pressure inside a system, and it controls the flow rate of a fluid system in a hydraulic system, flow of hydraulic fluid in a system. So these valves are broadly used both in hydraulic systems and pneumatic systems. So the direction control valves determine the path through which fluid traverses in a given circuit. The pressure control valves protect the system against the excessive pressure. Wherever the system pressure increases certain value, so this pressure control valves comes into picture and reduces the pressure, protecting the system, which may occur due to higher actuator loads or closing of valves. Then the flow control valves are used to control flow rate in various lines of a hydraulic circuit to control the actuator speeds. So, coming to the directional control valves, as the name itself indicates, it controls the direction of flow of a fluid inside a hydraulic system. So these direction control valves are abbreviated as DCV, capital DCV, directional control valve, and these valves are represented by symbols. So instead of drawing the complete valve, it is easy to represent the symbol by a valve by a symbol. So these figures show the symbolic representation of valves. The first figure shows each individual switching portion is shown in a square. So if you draw a square, the meaning of that symbol is each individual switching portion is shown in a square. Then the second figure shows the square with a filled arrow. Flow path is indicated by means of arrow within a square. That is, there is flow. If you indicate with the arrow, there is flow in that system. Then the third figure shows the closed position of a valve. If we want to indicate, then it is represented by the third figure. Then if there are two squares and if it is written as BA or AB, it is called as two position valve. Then we have three position valve represented by B, A, and in between we have 0. So that is called as three position valve. So this is called a symbolic representation of valves, wherein it gives very easy to identify the valves, identify the flow rate, identify the direction, and in a hydraulic system or pneumatic system. So these are the graphic or symbolic representation of directional control valves. Then the next is ports. Ports added to the first figure in this shows the ports added to the two position valve. AB is a two position valve, and if we represent AB, capital AB and PT, top and bottom, that is called as the two position valve represented with ports, different ports. The ports are represented by AB or PT. So this represents the ports added to the valve. Then we have the two flow paths. So there are two flow bidirectional valves wherein the flow occurs in both the directions. It's called as two flow paths. The second figure shows that. Then lastly we have two ports are connected, two ports are closed. So in the figure we can see two ports AB at the top, and then we have two ports TP at the bottom. It shows that two ports are connected and two ports are closed. So these are also graphical representation of the valves. So this is about directional control valves. So the directional control valves, this session we have learned about the course outcomes, course objectives, then the components and hydraulic components, different components, directional control valves, definitions, pressure control valves and flow control valves. In that we have learned the graphic symbols, how to represent the directional control valves, which represent the direction of flowing hydraulic fluid, and the graphic symbols for representing those directional control valves. Thank you.